So in this example number 1, Hong Kong has a population of 7.2 million people and a land area of 1,100 square kilometers. The annual average per capita, so this is per person, primary energy consumption is 110 gigajoules. Would it be reasonable to expect that Hong Kong's energy needs could be met by solar energy if the entire country's area was covered with photovoltaic collectors? Consider an overall time average insolation of 200 watts per square meters. So the question would be, if ever we cover the whole of Hong Kong's country with solar PV, then are we able to provide that capacity or generation of electricity by solar PV alone towards this number of people and this primary energy consumption? So that's going to be the question. So let's list down all the given first, so we'll know exactly what values are given. So we have a population. Population is given as 7.2 million, right, or 7.2 times 10 to the 6 people, right? And also we are given a land area. So the land area is 1,100 square kilometers. And also we are given this 110 gigajoules, which is the per capita primary energy consumption. All right, so we can say that the energy consumption per person is equal to 110 gigajoules. Right, so that's per person, per capita. And also we are given insolation, which is insolation, or the irradiance in this case is 200 watts per square meters. Okay, so this question is, we have to see if the overall energy can be met by solar PV covering whole country. So this is the question. So what should be our first step towards determining if we can answer this question of having to meet the overall energy demand? So the first step for a solution is to determine how much is the power energy consumption per unit area. So in this case, everything is given here. We have a land area of 1,100 square kilometers, and we also know the population. So in order to do this, we need to solve first for population density. So population density refers to the number of people per unit area. So in this case, we can put the population density as population per square kilometer. So how many people can is actually how many people is the density of the people in an area, specific area. So in this case, we are given 7.2 million. So this is 7.2 million people, all right, and then per the whole area of Hong Kong, which is 1,000 square kilometers. So the answer for this is 6,545 people per square kilometer. So that's the population density of Hong Kong. So that's quite very highly dense, one of the highly dense cities in the world, or countries in the world. So the next step would be to see how much is the average annual energy use per square kilometer. All right, so now we know that these are the number of people here. So now we need to calculate how much is the energy used for that number of people. So there are 6,445 people per square kilometer times this given of 110 gigajoules per person, right, or per people or person. Then we can calculate that as an average annual energy used per square kilometer is 7.2 times 10 to the 14 joules per year, right? And per square, this is per square kilometer, all right? So now we need to compare this amount of energy consumption to the energy generation. So the solar energy generation by PV, solar energy available or generation, which is this one, should per square kilometer, so that we will have a good comparison. So since we are using per square kilometer there, it should be per square kilometer. So the insolation is given already to 100 watts per square kilometer, per square meter, I mean. So we need to convert this one into kilometer, all right? So we need to convert how many meters in 1 kilometer. So 1000 meters per kilometer squared. So now is conversion to square kilometer now. Then we need to convert the watts into energy. So we need to convert that one. So there are 3600 seconds per hour times 24 hours per day, right? Times 365 days. All right, so in this case, since watts, okay, watts is joules per second, all right, so we can cancel the second here, hour, day. So what happens is only joules is remaining. So in this case, the answer is equal to 6.3 times 10 to the 15 joules per year per square kilometer, right? So this is the solar electricity generation by solar PV. So if we compare now that solar energy generation towards the compared to the consumption, we can say that, okay, I will put it on top here. So 6.3 times 10 to the 15 joules per year per square kilometer is greater than 7.2 times 10 to the 14 joules per year per square kilometer. So this is generation, this is consumption here. All right, so because this is greater now, so it means that basically the solar PV can supply the amount or the needed amount for energy consumption of the entire country. Now, what can you actually notice from this problem? So what you can notice from here is that efficiency of the solar PV was not given. All right, so we are assuming that this answer here is 100% efficient. So let's consider if at 20% efficiency. So let's say at 20% efficiency, this value now becomes 1.26 times 10 to the 15. So this should be 15 also. Yeah, should be 15 here. All right, so okay, I'll just have to make sure that it's clear. So that should be 10 to the 15. So the value for the 20% is still bigger than the value here, right? So it's still possible at 20% efficiency. Most solar PVs are actually at the range of 20% efficiency. So at least in this example problem, it can show that by covering the entire country with solar PV, it is possible that it can provide the needed consumption for 7.2 million of people in that specific area. All right, so that's going to be our answer. The answer is it's possible to provide this one. So this answer is possible to provide. All right.